Morning, Rich.
Good morning.
Give a few more minutes for others to join. Hi, Robert. Good morning.
Good morning.
Give a couple of more minutes for others to join. We have couple of items in agenda today. I was kind of hoping to review the PE white paper as well as any feedback from there. And also we have upcoming presentation in the regional summit for IUE. One of the thing is we have defined system level, and also we want to kind of make sure that track level and DC level representation looks good. We want to get some input from the team today. I know it's a Good Friday. Hopefully people can still join.
Yeah, my company used to have this as a holiday, but we currently do not.
Yeah, we don't have it also. Are you planning to attend the regional summit, Robert?
No. Okay. Since COVID, I haven't traveled.
Are you able to join any of the previous meetings, or you are joining first time today?
Joined the one last week.
Yeah, sorry, I think I had a problem with the network. I was not able to join last week. Ended up joining very late after you guys left, actually, after 40 minutes or so.
We talked a little bit about how, like, I gave an example in Texas. The Texas grid has real-time dashboard showing where the energy is coming from and how much is being consumed.
Oh, good. Okay.
And it'd be interesting if data centers could utilize that information somehow.
That's a good thing. If they're able to represent from where it's coming, at least they can correlate the energy, how it is coming from sustainability perspective, right?
Mm-hmm.
Maybe while we are waiting for others to join, I could probably update you on a couple of things so that I can get to speed on some of the work we have done. Let me share screen. Are you able to see the presentation?
Yep.
Okay. So what we are kind of going after is if you look at PUE, the way it is measured is data center energy is coming in, and you have classified as non-IT energy and IT energy. The non-IT is all power converters, heating, cooling, and the ancillary spaces. Then the energy is going to the IT equipment. And if
I
you look,
understand one
right.
problem with this is like the fans inside the IT equipment are
not
charged
right?
on the IT side, not on the cooling side, which.
Right. And I think that's what we are trying to say. If you take a computational thing, we need to account for thermal power and idle losses. If you remove that, the remaining thing is going to the computational power. And we were not, if you try to do the normal PUE mechanism where you go back to PUE, energy consumption is the bottom and the total data center energy on the top. So when you're operating idle power, then it goes to infinity. So we kind of switched the metrics here. We're saying total power on the bottom and active power on the top. So this is how we are basically saying total power is whole thing, and active power is what is going to the system, and the computational power is one we are putting in the top. So the maximum value is 0 to 1, maximum value is 1. So that at least we can represent at a system level. Then if you go to the rack level, the way we are thinking is all the systems within the rack, if you add them together, all the computational powers divided by all the server rack power, you can think of it. So I think want to get input from the team. Is this looks okay? Do we have any concerns here?
Well, the thing that occurs to me at the rack level is you have bus bar-based racks where each server doesn't have a power supply, but the power supply is shared at the rack level across all the servers. So will this reflect that better?
Yeah, so so that's why we are if we are not able to, let me see whether I can do that. The theoretically what we are saying is all the server power combined together. So in other words, totally rack power that is going into the rack, right? It's equivalent. On the bottom side. And the top side is it's all the servers compute power, right? That's what it's we really after that, right? This can be measured. If you go back onto the rack, you can say this is the rack power. Even if you have a DC bus bar, you can whatever going in, it's the rack power going in.
Oh yeah, it's like
that I was kind of thinking like we can put the bottom is a rack power and the top one is all the computational power from all the servers or network, however we want to put them through the right.
Well, I didn't follow so much, but the more I like look for you. Yeah.
Do you see any concerns here representing this way?
Yeah, no, it's like that.
Well, it seems like in the bus bar case, this was correct, but you'd have to say in the bus bar case, the previous per server calculations not be possible.
You mean the top one or bottom one?
The previous slide that had computational power server.
And this one?
And so it just like
Or the previous one?
I agree that at a rack level, it should work for both bus bar and non-bus bar systems.
Correct, correct.
And in a bus bar system, I don't think you could come up with a number for the individual servers because of the way that power is shared.
Right, right. So as in this one, basically, like you can say, like for traditional servers, this could be the one when it is a bus bar. This could be the one, right?
Yeah.
You can use either metrics depending on where it fits. But you're right. I think it will be good to mention that way it's clear. People can understand. Let me make a comment here.
Oh yeah, I see on the equation on your screen the sum of server active power.
Right.
That would be impossible on a bus bar.
Correct.
Oh, thank you so much. I got like out of the screen away and I saw.
Oh my God.
Yeah.
I've just been getting familiar with these terms lately. I saw there was also a paper years ago created a metric called TUE. That was TUE. That was trying to replace PUE, but move the power consumption of fans and power supply efficiency over from the right side to the left side.
So do you have any link to the paper?
Yeah, let me.
You can have share this.
I'll paste it in the chat.
Hi there.
Right now.
Did you post Robert or still looking for it? Okay. Or you can post it.
Trying to get the chat window to pop up. Oh, here
Okay.
it is.
Yeah, good. Thank you. Yeah. I will take a look at it. And so I think it's a government site, right? So it's a good thing to note.
So I was curious what happened to that as a proposal. Is the industry adopted it or not?
It looks like ISC 13. That's probably 10 years old. I will take a look at it. Yeah, thank you for the link. So then I think if you're able to do a rack level, what I was thinking is for a DC level, it's a sum of racks. Like you can think of whether it's a rack or immersion cooled or however it is, right? We can call them is an immersion cooled compute entity is a rack from representation perspective. So what we are doing is sum of the the racks. One here.
Yeah.
Then you can even say either you're summing up each rack, or it can be total IT energy going to the all the system in your IT. So when we go on the top side, it's sum of the computational power from coming from each rack. So if we are able to sum it, it is similar to what we are doing in a rack, but we are saying it is a sum of that. So that is, if you really, I think this I need to look. I keeps moving.
So one comment I've heard on this concept of summing,
Mhm.
Because all the numbers have large uncertainty values, and there's really a minimum, maximum, and typical. And if you end up like summing the worst case numbers, you can get numbers that are not really true because they're so pessimistic. In
That
some
is,
cases,
yeah.
people recommend doing like a sum of the squares kind of calculations to get more realistic values.
Okay, so it's basically like you want a kind of mean average with the square rather than just a plain sum, right?
Yeah.
It amplifies that. That's a good point. Let me make a note of that.
I'm not totally sure when that's the better way to approach it, but it does seem like the simple sums
May I have this to go, please?
can be
Yeah.
insufficient.
That's we need
Top it
to
off. Be good.
probably populate some example numbers and do the calculation so that we can see whether how that numbers look different, right? I think one of the work what we are saying is once we feel comfortable on this formula, I think we want to create some model or Excel sheets with various numbers
Thank you
and
so much.
populated them. And I believe Rich, is it noise coming from the background from Rich? Right.
Yeah, it sounds like Rich is
I'm gonna go
Motion.
find something for Easter to cook. Yeah.
Let's see that I can
Coming up.
mute.
Yep, thank you.
It's gone. So it's one way of kind of thinking is the load. Then I was kind of even Eric was kind of saying, hey, can we represent PUE in terms of IUE? Then it becomes much more. At least we can understand what is the difference looks like when you are putting IUE, right? Then I spent some time to see like, hey, PUE is the total energy going into the data center and how much energy is by IT. And we can also say like it's a computational power plus non-IT power. Then when I was looking back the formula, it looks like IT power consumption that is easy to calculate.
Yeah, I think this is what that TUE paper was about, was creating a metric that
It's something
can be
similar.
converted to PUE based on IT efficiency.
Okay. Yeah, I will take a look at it. If it is kind of similar, and I think if there's some alignment there, and then we can say like it is kind of matches, or if we see some deltas from there, we can highlight. at the end, I think all these things, what we are really trying to go after is this profiles that we want to generate, right? The way we were kind of thinking is, what are the things needed for measuring power consumption, what we need for ideal power, and what you need for power conversion loss and thermal power consumption, right? So this is more kind of a OCP system level that we could provide, so that these matrices are coming out of the system. Today, I don't know, we probably don't have a matrix of how much fan power is consumed, right? Or we don't have a sensors to say like how much fan is consuming. Not probably in a standard way, right? The thinking is, hey, can we put some at least red-based representation so that we can say there's a mechanism to represent it. Then it's based on the systems, people can do some static calculations, or even if in future they provide a dynamic ones, then we can able to use the same profiles or same schema from red-based, then we can use and calculate it.
Yeah, I think this is one of the things we had noted too. There didn't seem to be a standard for reporting fan power. There's some ways you can infer what the power is by like fan RPMs, but that would require knowledge of the fan model to know how much power it is using per RPM.
Yeah, BMC does send the either voltage or the pulse PWM to kind of give a speed, right? So you could potentially do a measurement offline and bake into that formula, right? Based on how much BMC is trying to push the power limit, they can at least not, if you don't have a real sensors, you could probably derive some values based on what BMC is sending commands to the fan.
Seems like, to be fair to the system, also needs to report the input temperature, the output temperature. So you can tell what the fan is doing and what it's not doing. How much power is going into the server and being converted into heat.
So this you're looking from the sensors perspective, right? I do know there are profiles available in the hardware management. I think what we really need to, the baseline, if you look at hardware management. Yeah, there are properties there. I will go back and look what are the properties there, but I'll definitely am making a note. Having that will be helpful from, or what you're saying is it's needed if BMC need to drive certain decisions, right?
I'm thinking more about the PUE metric and making sure we're measuring all the inputs and all the outputs to the system, whether it's a system level or rack level or data center level.
Okay.
And one of the outputs of that system should be heat.
Okay, that's a good point. I'll make a note.
Because if you imagine the system is running the fans at 100% and keeping it cool, that's using power, but there is a benefit for that versus a system that doesn't do that, just heating up the environment. It may look better on a power consumption basis, but is it really better overall?
And maybe let me go through the different metrics here, right? So power, we are thinking like we need to have max rated TDP and the active power going to the system. And if PSU is present, you also need to get the power readings and fans and voltage regulators. And probably also need to have a device level so that when you're trying to root cause, we have all the information available from who's consuming what. So the this information is kind of useful. Do you see anything more that we should be considering here? And we just put as an example because we don't call out these are finals because we want to get enough inputs before we can say these are the final ones. And if you're
One,
going
so these would be the actual. There's both the actual and then there's like you say, the rated power or the capacity.
Yeah, max capacity.
In the new European Union regulation talks about compute capacity, asking you to report spec performance benchmark numbers for each server.
Says picking trait.
No, it's the numbers used for Energy Star.
Okay.
Whereas Energy Star's the efficiency number, there's also a performance value. And the EU regulation is asking that you sum up the performance values that your servers are capable of doing.
Do you know what metrics they use, what benchmark they use to say the performance value?
Yeah, I'll paste this in the chat too.
I think one of the paper I read was people were looking at comparing performance, and finally they said there's no alignment on what performance to pick. And I believe that work was done 7, 8, 10 years back, and not sure there's any active work is going on. I believe on the white paper, I don't know whether Rick, you had a chance to review this. We were kind of, I think, few of the references that we used. I will go back and look if any performance thing we can also add. And is that looks like kind of latest? Do you know the summary of it, Rick? Is it adopted or is still under consideration? I will take a look.
And so the regulation was adopted. I think it's got some things that go into effect in June this year.
Okay, okay.
It looks like it was adopted, but the draft still says draft, so it's clear the adopted version hasn't been posted yet.
Oh, scroll down, there's a adopted version at the bottom of that page.
This one.
What, the annex? Is that?
Keep scrolling down below the feedback. There's the adopted.
Oh, I got you.
Ah,
Yeah, I see it.
okay,
Thank you.
okay. Okay, that's a good point. Let me take a look at. When Deborah was pointing, there is some work on the SERP, and if it is adopted, then it's good to look at that and call out what it is. Okay, I'll make a note. So do you think we need to kind of have a performance as another metrics that we should capture?
Well, I think here, in addition to the metrics of the actual usage, getting the capacity, possible usage would be what would be needed for that regulation.
Okay, okay. Okay, that's a good point. I will take a look. Then we were kind of spending time on idle power. I think this is where I think also some alignment needed. I think what we are saying is idle power is no workload is really deployed, but system is booted, right? Or even if it is booted, there's no output of work is produced by the system. You probably have idle threads running and it's just waiting for work to be scheduled. Still, you got a part of the infrastructure sitting there. Thinking here is either you could initially start with some static value, and it's possible when the system is booting, you could before the workloads are scheduled, you could measure the power and you can report the decided power. And one of the thing is, if you have a shared stuff or you are hot adding the additional devices onto the system later, however we want to go and deal with it, right? Because when we say idle power, people can say like, hey, I just put it a simple CPU, but all the remaining things are going to appear later. So your idle power is not really a good representative of what the device is going to be active when the system is running. Again, we do need to have a more discussion and align on what we really want to represent it here, right? What is the real metrics we want to use?
There are also different levels of idle. Like idle could just be the system sitting there at the prompt with nothing happening.
Right.
Or it could mean it's powered down. Your PMC is powered, but the server is no power.
Yeah, it's like S3, right?
Yeah, and
It's
consumer space, S3, S4, S5.
right. I think, but our kind of thinking here is, yes, that is, yeah, another parameter. I believe when we are kind of looking, I believe there was some graphs. I think we are. This one really like maybe a multiple range here, right? If you want to compare it, where are we operating? I mean, if a data center is operating in S3 or S4, that's what we want to measure, then we should call out that. But you're right. I think people can until you're even if in S3, unless it comes back to the real active, it's still not producing any output. Only it's producing output after it comes out of S3. Right? But also you're right. I think if you're whenever it goes to that state, you're going and putting in S3 or S4, even S5. How we want to comprehend that, right? It's a debate. I believe question is, are the data centers are they using effectively, right? You could have a state, but if it is not used, it's not going to be
Really,
yeah.
Yeah, if you have servers that are used 24/7, they may never go into these states. Other
Correct.
servers might go in for 8 hours every night.
I think that's where that load comes into the picture, right? I think even zero load, I think what you're saying is there are 3 states or 4 states under the zero load. I will again also make a note.
Yeah, I think if servers are capable of saving more power in those kind of states, they should be recognized for doing that.
And I think I'm making notes. We will probably need to come back and have a discussion on those items there. On the power conversion loss, we were kind of looking on, given we are talking about IT, anything power losses before going to IT, I think it's already accounted in part of PSC, PUE metrics. So now we are looking on only the IT side of it. So we want to consider the PSU as well as DC to DC conversion loss. And PSU can be shared if it is like BC bus bar, it's sharing across the systems, or even you can have a individual ones, or you could have boundaries. So within the rack, you have 2 DC bus bars. If you want to separate it out, then you need to have a mechanism to represent that. But regardless of that, there are losses coming out of PSU you want to account, and is it a smart power supply or not smart? We are able to measure both input and output, or we are able to only measure input, right? So we need to account all the variations so that representation wise, at least we can able to represent. But at the end, what we are really looking for is what is the loss occurred by either PSU or DC to DC conversion. anything in this area that which are about you see that we should be addressing.
Yeah, I don't have any insights here.
Okay. So we kind of touched on thermal. So any comments on the CDU side? Cooler distribution units.
What is CDU?
Cooling distribution unit, for example, if you have a both you could have a secondary cooling loop. It may going across servers and it goes to the rack coolant distribution unit, which takes the heat out of it and send it to the primary to the chiller, right? And that again, this is a traditional one. It basically goes to the towers and other coolers. But when you have immersion tank, your liquid is going in and gets circulated, and the CDU is the one taking the heat out and sending it to the facility to cool. What we are talking about is how much power is consumed by this guy. And the power consumption, because this is going to be sitting inside the IT racks, not in the facilities. If it is accounted as part of facility, then it goes part of POE. If it is not accounted as part of facility, then it goes under the IT side.
Well, one question for you on that.
Right.
There's a new generation of CDUs as end of rack row CDUs, which is kind of not in the rack per se, but it's in the rack row. Would you still
Okay.
count? How would you count that? Yeah.
I think the basic question again comes back to is it accounted a part of POE or is it IT, right?
Well, I'd count it in PUE, but well, I'm open to other thoughts. It could go either way, right? It's typically at bookends. It's at the end of the rack rows. It's not necessarily in the rack directly with the server, but it's clear the server wouldn't operate without it. So I would count it in PUE.
Yeah, I think we do need to put at least as a schema's representation, we need to put a facility side to represent that.
Yeah,
And
it's almost like an external power supply. It's
correct,
like
correct.
it's essential to the operation of that unit. Now, sometimes you can have a CDU that
Right.
isn't essential to the operation of the unit, and that should be considered IT. Right?
Correct. Yeah. Either essential or non-essential, if it is a accounted part of the IT, right? We should include in this IUE portion. When you say non-essential, you're kind of looking at the facility side or thinking of the IT side?
Yeah, I mean, essential means you should be able to boot up the product and operate it for a few minutes without it burning up.
Oh, okay.
If you tried to do that with a direct-to-chip server,
Right.
that's using an end of rack row CDU,
Right.
it would burn up. It's not designed to work that way. So my point is sometimes the CDU is in rack, sometimes it's at end of rack, but it's not always in PUE. You have to make a determination on the design of the servers it's serving. It's hosting, it's cooling.
Yes, I think that's a good point. I think how do we represent, make sure that it's a PE is not accounting, IE is not accounting, and then it goes out of the things, right? Yet, and also you don't want double count. I think, yeah, I agree with you. Yeah. Yeah, I made some note here, and we will also represent that another picture. We can add that so that it's complete. Yeah. Any other thoughts, questions on this? Otherwise, I do have one more question for this thing here. So I don't know, Rich and Robert, did you have access to this white paper, or do you need to give you access?
I'll need access, please.
Can you type in or send me your email address, especially
Yes.
Gmail generally works better on the OCP Google Drive, unless if you are able to access. If you have OCP address also, email, that will be good too.
Is there a link to that on the wiki page or?
And no, it's not in wiki. It is. I send it out to this link to the meeting
email?
email.
Let me look.
I pasted the link here. But I think in order to give access, I need the email address. Or you can send me that. Once you send me the thing, I will add it. So what I think this white paper, I think we were hoping to get it reviewed and release it probably another month or so. This white paper really like kind of complementary to the IUE discussion. This is really trying to kind of say like, what are the problems exist and what need to be solved rather than giving a solution. So you can see a lot of pictures, everything is coming from the other presentation that we are having it. Couple of things I was kind of hoping to get a alignment is the load. When we say load, what is that we want to mean? And also like Rich, you pointed out, right? We need to look at that Energy Star performance things, and maybe there is some wordings that we could use and explain what that means on the performance side. What I put here is make it a little bigger. Percentage of output produced by the compute unit compared to the maximum possible performance or peak perform capacity. And if it is ideal, it is 0. If it is a peak, it is at 100. Anything in between, you can say like it's divided by the peak capacity by how much it's producing. Again, the main factor is I think we are using the load as one of the parameters in our representation so that you can compare. So we want to define what is that load means a little clearly so that people can align to the same definition. And I believe you read through this paper, I think all trying to say is all the different problems we are trying to solve. Where are the gaps that need to be addressed? And one of the things we really like not putting in the IUE white paper is related to the WE. What we are saying is, unless you know how much temperature of that water is going into your data center, or what is your environment conditions, you may not representing what do you call, you could have an ideal data centers operating in 2 different regions, but it can produce different PUEs. So we need to understand that when you want to compare, you want to understand the geo portion of it and the water, how it is going to be accounted. There is two different things that which is not, we are not addressing as part of IUE. But all the remaining thing we were talking about, it was we are trying to address in part of IUE. And this paper is just to trying to highlight what are the things we should be considering when we are looking at PE, what opportunities there to kind of address. And we are trying to kind of conclude with this is metrics work going on, some white paper we are developing. And I believe I added some of this one here. We probably need to align on the performance side too. So yeah, so once I get your things, so you already provided, yeah, I will go back and add after the meeting. Those two, and another quick question, Rich or Robert, have you seen the sustainability profile matrix definition from Jeff?
No.
Okay. I think one of the other things we want to do is we want to turn the work that we are doing, not here, I believe, around. We want to turn that as a sustainability profile, and we want to represent as part of the red space. Under that, what we want to say is whether system is representing carbon, embedded carbon, or is it representing IUEs, or even any performance related things. Like if you say we are representing it, what are the minimum required items? Because you can say, like, if I want to calculate IUE, unless I have ideal power, we cannot really calculate IUE.
Yeah, I think it's very important that we make sure Redfish reports everything that needs to be reported, and we identify which properties are important for which purposes.
Right. And what John and Jeff was asking is this our Workstream, this one, at least for IE side, go and identify all the required items and what is the optional items, and include in the use case document so that they can take that document and translate into the profile. As part of this, I think the reason for kind of creating this metrics needs to have that discussion, and probably next week, what I'm planning on doing is put the table required and optional items, bring back here for a review, and we can get some alignment so that we can give it to Jeff and say, like, hey, can you populate some example profile? then we can reiterate back and finally before really saying yeah, everything looks good, right?
Maybe I'm missing something, but to Robert's point, I believe everything's already in Redfish to do that, but is there something missing?
Yeah, so for ideal power, for example, we don't have a clear representation from Redfish, so we have to ask them to include some additional things there. And for example, fan power also, right? It is not consistently available, it's optional. But if you want to say IUE is required, you need to have the non-IT computer if you go back to this one, right? If we can get all the 3 items, we cannot calculate IUE. It's probably optional, but when we say I'm supporting the sustainability profile, and under that, if you say I'm supporting IUE, then all these things becomes required item rather than optional items. Make sense?
Yeah, it makes sense. Okay. When you say required profile, you don't mean in the context of the EU regulation, you mean just required for OCP.
Correct.
Yeah, okay.
Again, I think there is a lot of, you can see from even today's discussion, right? Ideal power, there is multiple states. And all the fan and other things, we have multiple things. I don't know whether we want to do the performance, how do we want to look at it, right? I think let us start putting together some initial pieces, then we need to have some multiple conversation to finalize what we really want to say, which is really required and optional. And even if it is required, then there should be a higher level profile things they can say, yes, required or optional, or that final decision we need to do. I'll bring in the initial thinking for next week for us to discuss. But it might need another 2 or 3, 4 months, at least to work to kind of finalize it, right? It's more of for a global summit target rather than immediately we can do it. Okay, any other inputs? Sorry, it looks like Eric, we have a spring break in Oregon. I think few people were taking a break and they're not able to join. And thank you for all your input. Let us
Sammy, just real quick, could I get access to the slides as well, or is that already in the work group? How do I see those?
This slide.
Yeah.
I submitted for the OCP summit. I could potentially post that in the same SharePoint. I have the document here.
I think that'd be helpful because I'm trying to edit my Lisbon Summit presentation right now, and I think I need to sync better with what you have here so it lines up for warranty.
Okay, I will put it in the thing and send you a link.
Okay, thank you.
Okay. Then good having a conversation today, and have a good day today or weekend, and we'll see you next week.
Thank you.
Thank you.